There's a word for what you just described, Scott, and that is technology leadership.
Appreciate you saying
It's
that.
hats off, we don't know what to say, right, Fabian? It's like, okay.
Yeah. Absolutely. Especially after listening to Chris, and then I said, oh, I have to ask you about Rheocasting for structural casting to get your 4,400 ton machine into a Giga casting machine. And then you explained everything with me even not asking it.
I think I go and boil some coffee in my kitchen instead. So.
Yeah.
better use my time. Hand over the microphone to you guys.
That was really amazing.
Hello and welcome to the Gold Casting Podcast. Yet another episode, and this is a very special one because we hear a lot of things about the US, pretty much about good things and sometimes less good things. But one thing that is very important for us is the design trends and also the introduction of Rheocasting in the continent of America. And to really dig into this, we had the pleasure of inviting two gentlemen from Spartan Light Metals Inc. in the US, Mr. Scott Meyer and Chris Leaf. So, Chris and Scott, warm welcome to the podcast.
Thank you very much.
Yeah, thank you. Appreciate you inviting us on.
Yeah, the pleasure is ours.
Exactly. We're grateful to have you here. Can you give our viewers a short introduction of yourself?
Yeah, of course. I'm Chris Leaf. I've been in the automotive industry, best part of 30 years now. Yes, I'm old. You can probably tell from the accent, I'm originally from England. I've been here in the United States for more than 20 years now, but I've worked for multiple tier ones and a couple of OEMs over the years. A lot of my background is in body and white, stampings, obviously casting for the last 7 or 8 years. And a lot of it has been in the commercial side of things, sales roles, but at heart, I'm really an engineer. My degree's in engineering, and I've been fortunate in the last couple of years to step back into that and have a fully engineering role at Spartan now. So,
hello, my name is Scott Meyer. I manage the central engineering department at Spartan. We do design, analysis, and R&D work for all of our 4 facilities. My background has been primarily in casting since the late 90s. As I mentioned, about 8 years of that time has been with Spartan. I also did a lot of drivetrain design, large housing design for a large yellow construction equipment manufacturer in the U.S. For about 16 years. So, yeah, glad to be back at Spartan, though. Glad to be involved in more of Spartan's R&D activities. That's really where I like to be. The team and I roll up to Chris, and we really enjoy the opportunities that he and Spartan give us.
Oh, that's great. But Spartan, what is Spartan? Chris and Scott, could you give us a brief overview of Spartan as a company?
Yeah, absolutely. Spartan, we were founded back in 1961 by Henry Jubal, and we're still privately owned today by the Jubal family. Our chairman is Don Jubal, who is the second generation, and looking forward to the third generation. Don has 3 children. Melissa is currently working as our VP of Program Management over at Spartan. So looking forward to many, many more years as a family business. Honestly, as a family business, it's a really, really nice place to work. It is a very different atmosphere to a lot of other big industry. Over the years, I've worked in large private and also public companies. And I can honestly say that the atmosphere, the camaraderie, and the willingness to work together as a team for the good of each other is much stronger at Spartan than it's ever been at any other company I've worked for. So the company itself, turnover was approximately 250 million US dollars. And we have 4 manufacturing facilities in the US, all based in and around the St. Louis area. We have Sparta in Illinois, which was our original facility. Then we have 2 facilities in the town of Mexico in the state of Missouri. A lot of people tend to get that confused. No, we're not south of the border. And also a 4th facility in Hannibal. We die cast, machine, and assemble. High-pressure die casting machines range from 1,000 tons all the way up to 5,000 tons. We've got 46 machines at last count, and have about 150 CNCs, along with a lot of additional assembly lines. Our main customers, a lot of the big OEMs, we have Ford, General Motors, Honda, Toyota. Probably 90% of our business is automotive. We have a little bit of commercial and lawn and garden business. If you happen to have a zero-turn riding mower, the chances are that the transmission housings on your mower were made in one of our plants. The majority of our business today is powertrain, although we're moving very, very heavily and actively over into the structural marketplace. We have multiple structural products that we make today, and we have quite a few in launch and future development. So that's it in the very, very quick nutshell. Scott, anything you want to add to that?
No, I mean, I second everything that you said, Chris. I mean, Spartan is first and foremost a family company, and they really focus on making those of us at the facilities feel like we're part of a family, and they really focus on the communities where the plants are set up. So, I'm from around the Sparta area. Spartan has been a huge part of the Sparta economy since I was a kid, before I was born. I've had family members work there. I was one of Spartan's first interns back in the early 90s. So that aspect of it, exactly what Chris described, that's really what brought me back to Spartan after a brief departure.
Must be very nice working for a family-owned company when the industry is in this turmoil that we're seeing around now. I mean, a family-owned business, according to me at least, is quicker to decisions. They don't need to rush around a couple of boards and different hierarchies. They can actually take a decision pretty fast, which I think is a success factor right now. Would you agree on that, or is it just my feeling?
Absolutely, you're right. Yeah, that's one of the other great things about being part of our organization. We look to the long term. It's not all about end of the month and what impact the share price is going to have and what we have to do to make sure we hit those goals. Don't get me wrong. Like every other company out there, we have a budget, we have targets, and we're all expected to meet them. But there is the flexibility there that allows us to really to follow in Henry Jubel's footsteps. He was truly an innovator, and looking forward to the future, new technologies was a really, really big thing for him. And it's great to be in a part of the group that Scott and I are in, where that's exactly what we get to do. We get to go out there, we get to look for new innovations from a product standpoint, from a process standpoint. And of course, obviously, Rheocasting, with first folks in the United States to have Comptech slurry maker and be working there. But yeah.
So let's jump to the question then, guys. R&D efforts. You have been up to pretty much lately. I actually don't know what I can talk about, so I rather let you elaborate over your R&D efforts. Now we're into the long-term investments here, guys. But could you please elaborate around what you have done in the R&D last years?
Yeah, of course. I mean, that's a great question. About 2 years ago, as a result of activities within the senior management team, the company has truly, really pushed towards a innovative, technologically driven, upstream approach to our business. And as a result, that was when I transitioned away from a commercial role into a truly engineering role. And we've been spending more time developing both product and process for Spartan, which we see will truly give us an edge in the future of die casting. We accept that we're never going to be one of the big boys, and we're never going to be one of the cheapest. But it is our intention to be the most technologically advanced die caster out there. So just a few examples of products that we've been working on over the last few years. One big one, which I think, Staffan, you remember from when it was first introduced last year at Eurogus, is our now patented all aluminum, single piece, high pressure die cast brake rotor, which is quite a lot of news. And for those actually who've never seen one, I just so happen to have one sitting here. That's all right. Now you don't have to look at me for the rest of the podcast. Yeah, this is a product that we've spent the best part of 5 years developing. We had the idea back in 2019 originally. where we were looking for opportunities to work with an alloy that Spartan had co-developed with NASA back in the 90s. And it was a very, very high wear-resistant hypereutectic alloy. And we were looking for areas where we could really put that in. And there were thoughts originally about using it for cylinder heads, particularly for the benefit in piston liners and avoiding having to spray in or put drop-in liners in. But at the time, that wasn't quite such an active idea. So we came back to it and have developed this. We started on a small scale with some small pucks, which were about 100 millimeters in diameter. We worked together with Southern Illinois University in Carbondale, which is about an hour from our Sparta facility. They have a department there who are dedicated to friction development, specifically brakes. They have dynos there. They have equipment for testing rotors, new pad materials. And together with them, we started small scale. We did a lot of FEA analysis. We ran the small scale tests. The results came back remarkably good. Actually, we were shocked. For example, the performance was very, very similar to an iron rotor with traditional pads. We didn't have to change pads. There was much less noise. And in terms of the wear was very, very similar to iron rotors. And we saw little or no deformation in the pads. So we then went on, with your help, Staffan, with Comptech's help, we built a die over in Sweden, and using Rheocasting, we made our first set of prototype parts, which we brought back here to the US. They were machined and they were tested on the full dyno over there at SIUC. And it was remarkably successful, honestly. There is an SAE spec, which I'm sorry, I can't remember the exact number off the top of my head, but we went about 80% of the way through that testing before we had any concerns, and they were more structural. A lot of the loading that we originally designed around from the dyno was actually much higher than expected. So we had some minor mechanical failures after about 80% of the testing. We've got a little bit left to go. We've done some redesign, some redevelopment, and we're hoping by the end of the summer we'll have full testing complete and be all the way through. But the great thing was, on the full dyno test, we saw no warping. We saw very, very normal pad wear, rotor wear. And yeah, we're really excited. We're sort of in the area now where we're looking for an OEM customer to come along and join us to take this the next step. Because honestly, we're die casters. We're not brake manufacturers. So yeah. In terms of this particular part, the original rotor that we based it on was on a large European sports SUV, and the original rotor was 33 pounds in weight. This rotor that I've got here is 13 pounds. So it's a 20-pound weight reduction for the same
times
performance.
4 in a vehicle.
Well, yeah, you have slightly smaller rotors on the back, but yeah, let's just say times 4. And when it's unsprung mass in the wheel area, that's huge in terms of ride handling and performance. So yeah, really excited about that. We do have a patent on it. Yes,
you do have a patent.
We kind of had to make sure it was protected. So, but yeah, that's one.
So definitely the best way to protect that is then with the patent. But I want to get back to the weight savings, as there's a difference between saving something like 30 pounds or 120 pounds for the force in a seat, which is just a mass moving, but on a moving mass, which is like connected to the engines or to the drivetrain. That's a massive saving that will be seen in the fuel economy.
Yeah, it will. Yeah,
it will.
Absolutely.
So, based the rotor on Rheocasting, and you invested in Rheocasting, what do you see in this process? What do you think you will gain from using Rheocasting for some applications?
One of the biggest things, I would say the most excitement that we've received to date has been on reduction in die wear. So, of course, if you read papers out there, some folks have said 4x increase in die life, right? The jury's still out on that, but we certainly think that a 2x increase in die life is very, very doable. We're in the process of doing some work in that space right now, but a lot of our customers are very excited about that. Then, of course, as you start moving into the structural space, we have customers that are very excited about the longer flow lengths that they feel that they can get with the slurry. Folks, of course, start looking at Mega and Giga castings. So that's first and foremost in so many OEMs' minds. But then in some regards, maybe most important though, just the reduction in trapped gas and the reduction in shrink porosity. So we're really looking for an improvement in the overall quality of the parts as well. But I'm not telling you anything you don't already know, guys. But those are the things that we're hearing starting to come back from our customers now, and it's nice that we're not having to push those things and educate our customers as much anymore. They seem to be coming to us with that knowledge in mind now, and that's been exciting for us.
But the new process, I mean, I know you have parts in verification phase right now. There's a lot of hurdles. How have you overcome them? I'm pretty curious because I've been working these 15 years and you guys are doing it in 2. So what's the secret?
We've tried to go with as few news as possible. And one of the key things here, I think, is trying to approach, our partner OEMs with alloys that they currently use. So we've been looking a lot at A380, looking at slightly lower silicon blends of A380, but something to give them a sense of comfort that this isn't something completely new that they've never seen in their application. It's the same alloy that they currently use. It's a different metal treatment process. And that's been helpful for sure. And then, to be honest, one of the things that's been most important to us is getting further upstream with our OEMs and identifying really the key players at these various OEMs in the R&D groups and the advanced structures teams, the folks that can really take these kinds of processes that we're talking about, rheocasting and some of the other things that we're doing, and really be able to see the potential for those things. So for us, getting into those people with the influence has been extremely important as well.
Yeah, I think for rheocasting, that's even more important. As for example, even if you use the same alloy, you get different properties or can do different things. So you need to talk to the design owners. And that's a big part of rheocasting, and the complexity of rheocasting is not on a technical level, it's on a marketing or business development level, and that's a great approach.
Yeah, no, I fully agree with you. It really is as much about the marketing side of it as it is about the engineering side of it.
But if we clamp them together, you have the A38 in the US, 226 is the correspondent alloy here in Europe, and then we have the 46,000, which seems to be a more Scandinavian, Northern Europe thing. All of them around starting 8% silicon. We see also good results. We're running more produce than not only the ones in the US, but the reduction of tooling, lower scrap levels. How has that worked out for you?
Well, I think some of that work is in process at the moment. I think we'll probably be able to get you some results here, hopefully in a couple of weeks. In reality, we have a trial coming up, actually starting Wednesday of next week again in house. So the early work has been extremely promising.
That's good to hear.
Yeah. One of the big things, Staffan, that we've come up against, which is, I'm sure, very, very similar to a lot of the other suppliers who are investigating rheocasting, is because the actual process itself is such a huge leap from an engineering perspective. And when I say that, I'm talking about you have to have very different gate and runner system within the tool. Potentially, to do it right, you have to build a whole new tool. And when you're looking at $250,000, $300,000 for a tool, that's very expensive, and it's a big investment for companies, especially when they've just invested over $500,000 to buy a slurry maker and integrate it into a mass production cell. So you have to take it in little steps to get little win after little win. And that's the way we've been trying to do it over the last 12 months in our slurry maker. We've done trials so far, but we've had to use mass production dies that are untouched. And looking at the parts, we've now been able to make parts that are very similar, slightly better quality than existing production parts, but we still have quite a way to go. And the hope is this next week, we've been able to take a die that's come to the end of its normal production life. We've been able to modify the gating to allow us to get closer, and certainly not where we would like to be to rheocast, but certainly closer, to show the true benefits that we can get from that. For example, the part we're looking at, it's a big ring. And if you're going to rheocast it, ideally, you need to center shoot it. You need a big sprue into the center and then fill it radially outwards. The tool we have today, it isn't like that. The gates come in radially from the outside and go through into the overflows. So it's perimeter gated, which is obviously very, very different, but much closer to what we typically use for our production. Long term, once we can show a significant improvement, then we'll be able to justify the part in production when there's a saving for us that we can go and buy that 3-plate center shot tool and then go one stage even further in terms of overall quality. So it's a difficult balancing act within an organization where they want to see quick results, but have already made one large investment and are somewhat hesitant to make a second one until you've really shown some progress. So we're taking lots of little steps to get there, but we are seeing positive signs. We really, really are. And next week is going to show that.
As always, casting is a big compromise.
Your approach is quite great, because usually what especially we are seeing is that we do a trial, okay, let's try it once and then bury it, and then you take your high pressure die casting to put it on a Rheocasting cell, and then you can claim you tried it and it didn't work. Yeah, that's usually how it is, and I fully understand the new tool is something quite expensive, but you can take several good things even from a failed trial with a high pressure die casting tool. That's okay. We can have improvements in these and these parameters and then go step by step, and that's something I think every R&D department can take a lesson from your approach.
Yeah, well, thank you. One of the most beneficial parts about the Comptech slurry maker is the way that it's integrated into the overall die casting cell. Almost with the flick of a switch, you can go between production with traditional liquid high pressure die casting. Realistically, in the time it takes you to change the die out, everything else that needs to be modified in the cell to run Rheocasting is done, and you're straight away. So you're not tied to that process, to that cell. The cell that we use, it's a 1,600 ton machine, and it runs production probably 60-70% of the time. So we're only able to get in small bites in production, and the ability and the flexibility of the process to let us do that is really beneficial to us from an R&D perspective, because I don't have to say, right, I need it for 6 weeks because I've got to have this huge upheaval. It'll be, right, I need a few days and we can do it. So no, that's a good thing about the Comptech system.
Yeah, and it really does make sense to our customers when they ask, well, why are you looking at this particular process, this particular equipment, as opposed to some of the other ones out there, maybe Feed, or they've heard about GIST or something like that. And you can very quickly show folks, apart from the obvious advantages, technically speaking, but you can very quickly show them from a system integration standpoint, and that ability to switch back and forth and the flexibility that gives you. Guaranteed, if you have folks with die-cast background in the room during those discussions, they immediately get it. They immediately see why that's an advantage.
Oh, that was so beautiful.
No, this is not a sales pitch for you, Staffan.
Yeah.
We're trying to be honest here.
Yeah, I mean the system sells itself pretty much, Staffan. You know.
Okay, so I'm fired now. Don't tell Per, but he's gonna get fired on Monday.
Yeah.
Hey guys, you said that you're transitioning from powertrain into structural casting, body in white, basically. I mean, you cannot have this pod meeting people like you without addressing the, as we call it, the naked lady in the business, Giga castings. I mean, that's
sure.
I mean, we're not in the most sexy business or industry in the world, but as soon as you speak about the Giga casting, everybody comes rushing and start to listen. I'm super excited to hear your take on the Giga casting trend development. Take it your way. So, what are your thinking about Giga castings?
Within our organization, I'd consider us megacasters. We have some metric ton, 4,400 ton FREC machines in our LMP facility. We have 3 there now. And potentially in the future, we might consider up to 6,000 ton machines. But honestly, anything bigger than that, unless you are either the OEM yourself or you're in a supplier park right next to the OEM, it just isn't feasible. Logistically, it becomes too expensive to move very large parts that don't stack well long distances to an OEM's facility. There's that. The other big thing that people talk about at the moment is the repairability of gigacastings. And if you have a part where either the entire skateboard, the entire rear end structure of a vehicle is a single die casting, then you have a small accident. And although we're very much a throwaway society here in the US, you don't want to be throwing away a $50,000, $60,000 EV because you've had a very minor fender bender. So it becomes very expensive to insure some of these vehicles, or if it hasn't already, it certainly is likely to. So yeah, there's disadvantages like that. There's also from a casting perspective, when you are so far away from the biscuit, you see very, very different mechanical properties. It's very hard to control those across the length of a very, very large die casting. So for us, we think it's possible, but it's very, very difficult. And a lot of people in Asia are buying bigger and bigger machines. It's like every other day someone's, oh, I've got a bigger machine than you. Now I want to get a bigger one. And a lot of these really, really big machines, there's not actually any business on them.
Right.
It's more like trying to one up each other in a region where capital really isn't an issue. There's a lot of capital support. So, let's go buy a 20,000 ton die casting machine that's just going to sit there, means something very, very different to a company over there to what it means to a company in the US, where we have ROI expectations for that equipment. Quite often we have to have a customer program tied to it before we're going to do it. So we were fortunate enough to be at GTK at the Gigacasting conference there a couple of months ago. And it was very, very interesting to hear a lot of the OEMs and a lot of the other folks talking there. And it seems to be, and gosh, I wouldn't want to speak on behalf of the industry, but it appears to be there is this segmentation in the 4,000 to 6,000 ton range where that seems to be looking to be where the cutoff is. But a few years ago, we would have said 2,500 ton was the cutoff point. Now we're 4,000 tons. Maybe 5 years from now, somebody will say, no, it's fine. Everybody's running 6,000 ton machines. We'll be there. So that's my take on it. Scott, what are your thoughts?
I think there was a really great presentation that was shown, a market study that was shown at that GTK conference, and really did talk about the various markets and the machine size utilization in each of those markets, specifically the China market, as you mentioned. And that was particularly eye-opening for me, just to see how much open capacity was there in that size range. But all things said, though, a lot of the technical challenges that are associated with creating a casting that might go in a 6,000 or a 9,000 ton machine, those are still challenges that we see even at the mega size. And we understand that our customers are really interested in being able to see how different alloys might flow if you have a 2-meter flow length, how semi-solid, as we mentioned earlier, might assist in that, how you might be able to get better properties at a 1.5, 2-meter flow length. So understanding that, we've tried to kind of address that in-house as well. We've been working on a new development tool that a lot of our customers seem pretty excited about. It's extremely flexible. It gives us the ability to cast about a 2-meter flow length in a 1,600 ton machine if we're running Rheo. It gives us the ability to swap out 9 different inserts. So we can come in there, give the customer the ability to make a brand new insert that's maybe I'm going to use our units instead of the metric system, but a 5.5 by maybe 8 3/4 inch insert. We can put in the customer's exact features, the fins, the bosses, any type of feature that they want to see. We can do that in a few weeks by cutting them into existing blocks that we have in stock. And we can run that in any alloy that's Rheocastable if they want to see. In theory, we could run it in liquid as well. But really to be able to give customers the flexibility to see how their features fill out with the process at varying flow lengths along the path of the tool without having to invest in a mega tool or a giga tool. And we've had a lot of interest in that. We have at least 2 trials coming up here in the next few months. And arguably, we have Oak Ridge National Lab probably getting involved with that project as well, further down the line towards the tail end of the year.
There's a word for what you just described, Scott, and that is technology leadership.
Appreciate you saying that.
Hats off, we don't know what to say, right, Fabian? It's like, okay.
Yeah. Absolutely. Especially after listening to Chris, and then I said, oh, I have to ask you about Rheocasting for structural casting to get your 4,400 ton machine into a Giga casting machine. And then you explained everything with me even not asking it.
I think I go and boil some coffee in my kitchen instead. So
Yeah.
better use my time. Hand over the microphone to you guys.
That was really amazing.
Technology is one thing. We're living on a globe. How is your global outreach? Do you have to go to the US to make business with Spartan? Or we also learned that Mexico's not Mexico. Mexico's a town in Illinois, right?
Missouri,
what kind of coverage do you guys have around the globe?
Well, up until recently, there was obviously just all our 4 facilities within a 2-hour radius of St. Louis. But over the last year and a half, we've been working together with a European diecaster based in Germany, and they have facilities in Germany. They have partnerships in China and India, and that allows them to have outreach there. They were looking for a partner in the United States who could effectively act as their North American arm. And I've seen it in the past. Say I've worked for large global tier ones, and when you're working with an OEM who has a platform, a vehicle that's going to be built worldwide, they don't want more than one supplier. They don't want a different supplier in every region. They want a single point of contact for development and for launch. And so we've reached a technical agreement with this company where when we're working together with global OEMs and we have a project that is in different regions for manufacturing in Europe and in Asia, it will be handled by the other company that I can share their name. It's KS Huayu Alutech, and their operations in Germany and Asia will manage that side of the business. Whereas for North American programs, Spartan will be the supplier for that region. And depending upon where the customer is, whether it's one of our existing customers or one of their existing customers, one or the other of us would take the lead with the customer, so that again the customer has a single point of contact. It allows both of us to have a truly global footprint.
But in those discussions, do you see a difference? I come from Greta country, Sweden, right? Where Greta Thunberg educating us all, especially white middle-aged men. And what we have seen here is that we had this tremendous sustainability thing going, and it was going to be CBAM in 2026 and yada, yada, yada. Now, all of a sudden, CBAM has been, pushed into 2027, cooling down considerably. So how do you appreciate the sustainability talks and pressure from customers in North America?
That's a good question, and it's a real lot of change at the moment. Up until about 3 months ago, we saw a lot of pressure, particularly led by the European OEMs who are based over here as well in the US, pushing for us to commit to long-term sustainability targets. For example, reduce your energy consumption by 2% per annum. Commit to be fully carbon neutral by 2050. Various other ideas that they have. But of late, within the last 3 months, with a new administration here in the US, and I'm trying not to be political and I'm trying to pick my words carefully here, that has been very much upended. Everything that people do, everyone who's in business, is driven by the bottom line and by making money and by profit. There's no point me trying to beat my way around that subject. That's the honest truth. And a lot of these sustainable targets that come out require expenditure on part of the companies that are trying to get there. And although we are pushing very hard within Spartan to move towards those goals, there is no longer the pressure from the leadership of this country to get there. And so we've seen quite a bit of a step back over the last few months. It's gone very, very quiet. And people are, I don't want to say less concerned, because people still feel the same way they did 3 months ago. But the pressure is no longer there to achieve it. From our standpoint, from Spartan's standpoint, we're still making strides towards it. Honestly, Rheocasting itself is one of the big pushes that we're doing. When you're running, and I'll go with American units here, when you're 110 Fahrenheit cooler with the liquid aluminium that you're pouring into the shot sleeve, you're saving a lot in energy costs. So that reduces your carbon footprint. You're also using smaller die casting machines. Again, smaller carbon footprint, lower overall cost. You spend less time on maintenance, so the efficiency goes up. So you spend less time running the cell. So for us, we see that as a big step forward towards meeting some of our sustainability goals. It's very, very difficult in the die casting industry. We use an awful lot of energy to heat the aluminium up, or whether it be aluminium or steel or zinc or whatever, but it's a very, very energy intensive industry. A lot of that waste energy from cooling comes off the furnaces. That's waste heat energy that can be used elsewhere. It can be used for heating the facility, for example. So we're actively looking into that as a company. But yeah, to answer your original question, I think as a whole in this country, things have gone on pause and gone on quiet for a while. And as to where they will go for the future, I honestly wouldn't like to predict.
The only thing I might even add, I mean, some of the really good material options that are out there, some of the lower silicon material options, great just from the material side of the equation, because you're able to rheocast it at lower silicon levels. And that's an area that we know we want to start looking into later. And of course, there's some real advantages there in heat exchangers and things like that. And then some of the great, for instance, crushed wheels, the ALSI 7s out there too. Mm-hmm. Obviously, if it's a crushed wheel and it's a high quality 356 type alloy, I mean, that's again so much less energy to prep all of that. And again, we're I think in a good position to be able to utilize those materials and those associated technologies as the customers and the opportunities come to us. So even though we may not be getting the political pressure to do so, we're still trying to look forward how we can utilize those technologies and
it takes
those
time.
opportunities. It does.
It definitely takes time. And also bring back a quote from you, Chris, earlier. Again, sustainability is also about money, because if you don't have to heat everything up that much and you can use the energy for other services, that's also cost savings on the other side. So sustainability is not just about making slides green and thinking about the environment. No, it also brings you benefit as a company.
It is interesting you bring that point up, because yes, there is the cost benefit there. From a process standpoint, there's another thing that I hadn't mentioned, but obviously, if you're scrapping less parts, then you're going to be using less energy. Of course, everybody knows there's a cost benefit to that. But another one of the R&D efforts that we've been working on is we've developed and again patented a new process, which effectively it eliminates localized subsurface and surface porosity in machined areas of a die casting. So if you have a part where you machine it, you have a particular area, a particular hole that's constantly opening up porosity, we can now eliminate that. And also we're continuing to work forward where not just to be able to do that in advance of machining activity, but we can now repair parts which have failed a leak test. I don't want to talk too much about that because that's still in the process of being developed and patented. But for us, it's porosity is one of the biggest scrap drivers that we have in our organization. And sometimes, as good a die caster as you are, you're never, ever going to completely eliminate all of the porosity issues that you have in some very, very complex parts. And we do have some very, very complex parts here at Spartan. I mean, that's what we do. We're known in the industry as the guys who take on the tough stuff. So to be able to eliminate that is massive for us.
There's a reason why we call one of your parts for the space trumpet.
I know which one you're talking about. Yes.
I've never seen so many vents in one casting in my whole life. I think it's like
no.
But one thing I see as a trend here now, leaving the script completely, is that in Europe at least, we all start with aluminum silicon 10, and then we start to speak about Giga castings and shock towers and all that. The big trend in Europe is going aluminum silicon 7. Do you feel it's the same thing in the US?
Yeah, I can certainly say that some of the customers we've been working with have been moving that direction pretty aggressively. And they're looking at that both from the standpoint of liquid and frankly, the standpoint of rheocasting. So for us, it's advantageous that they are heading that direction. But yeah, we've seen that aggressively in at least two of our customers now.
So it's the same thing, yeah.
I fully agree. Mm-hmm. I would expect more as we go.
It's a slow-moving industry, but I have the sense it's moving actually quicker in the US. But I'm super curious on one thing. You said you developed an alloy with NASA. We all see the coffee cups. It's not rocket science. Oh yes, it is. How did you end up with a development partner like NASA?
That was back in the day with my predecessor, Mike Garrett. He was, I would say, at Spartan, he very much believed in Henry Jubel's philosophy of looking forward, trying to innovate, looking for partners could help us innovate. And Mike was very actively involved in various, the International Magnesium Association. He was very actively involved in early development of things like B390 and any of a variety of different alloys. And so through a variety of different connections, he and the team at NASA were joined up with each other. And that's really where that partnership began. But yeah, that was a hyper-eutectic alloy, obviously. And yeah, Spartan did quite a bit of development work, early casting work for NASA. Actually helped to develop the high-pressure die casting version of it. The alloy was originally intended to be a low-pressure permanent mold alloy, really. So kind of helped them to refine the properties there, and then look forward to like the various tempers that they did.
So it was a driven guy with a lot of energy, with some good ideas. So that met someone at NASA, and then, as always, after a few years, ending up in a prosperous project.
Oh, I mean, Mike
also, if plan A doesn't work, then we go to plan B and C, and now we're back to plan break.
Don't tell the astronauts.
I mean, Mike always had a vision for where he wanted to take the alloy, for frankly, where he wanted to take Spartan. And I will say this, his opinions, his vision are still valuable to us today. I still consult with Mike once every 2 weeks. He's a fantastic resource for us. He still comes up with new ideas all the time.
So not only doing fly fishing and golf.
But Mike, like cycling. He's big into cycling. But
he's a big cyclist.
He provides a lot of context for why we went the direction that we did. But he's always looking forward.
Do you have any figure on how much you spend in R&D, like in percentage of your budget or something? Because it must be more per capita or in relation to turnover than other foundries.
You'd be surprised.
Okay, it's a secret number then, I guess. Let's leave it that way.
I would say this though, our efforts are involved not only with our own budget, but we also work to partner with a variety of other folks outside of Spartan, and that really does help us to expand the range of things that we can do. That's been key for us.
But also a cool thing, what I've seen it throughout your explanations, is that because you do all these R&D with Rheocasting, you have customers coming back to you, which also brings you new money for new projects and turn a big expense portion into a revenue portion. And I think that's also quite a cool way to do things.
You've hit the nail squarely on the head. That's exactly the approach that we're taking at the moment. And we're really excited. We think, year over year, those opportunities are going to increase for us.
Yeah, amazing. So you have to have your normal series production moved to something else.
That's right too. And we do have some more broad ranging projects that we're working on with some of our OEMs in the Rheocast space specifically. Some of those may be either later in this year or the beginning of next year as funding permits. But some of those projects, I think, have the opportunity to really lend a lot of production opportunities.
I think, sorry for becoming a little bit philosophical here now, but if you look at an electrical vehicle, compare it to an ICE, the ICE we have been fiddling around for 100 years. The EVs, they demand so much different thinking for the lightweighting, for the alloys, for the new systems, for the new brake systems where you are very well positioned. So if you don't have the tradition of development, I think you are in the second place from the start. I think this is the big differentiator that we will see, and I hope I'm right. And then I'll buy you a couple of beers in 4 or 5 years from now and say I was right because I had to buy them because you will stand me bragging. But I think you agree with me that if you don't have it in your DNA or your culture to be on the forefront, to be able to serve the designers, you're in second place.
Yeah, you're somewhat relegated to ending up in the truly dog-eat-dog commercial world of build to print, which is honestly that's not where Henry Jubal wanted Spartan to be, and it's not where that's true today. It's not where any of us want to be. We want to be out there. We want to be at the head of the pack.
Yeah. But some place where everybody wants to be is, of course, in a room with Spartan, and they will have the chance here in Europe as well, because you're going on a small tour. And January 2026, ladies and gentlemen, Spartan will be at the Rheocasting.
Yes.
And at least I am looking forward very much. And for those who doesn't know, there's a patron of the trade fair workers, Saint Kevin, and Saint Kevin will be there.
Yes.
Yeah.
And for you curious what it means having the acquaintanceship of St. Kevin, come to the booth where Spartan is, and we will tell you and explain, and you will see it yourself.
Absolutely.
And I'm sure he'll be more than happy to provide you with the beer. Yeah,
absolutely.
But funny you should mention that. Now it's a bit of obviously an inside joke, which started at the NADCA show back in October. But it does bring to mind one thing. I made a point of inviting all of our senior leadership to the NADCA show. And the one thing that I kept hearing time after time after time from them was, it's incredible the amount of interest that is generated around the Comptech booth. And every day, there were times when you simply couldn't even get up the aisle between the side where we were with you and the guys were across from us. We took up the entire area, and it was constant. And I'd love to say I'd put it all down to the technology and to your charisma, Staffan, but no, it was St. Kevin. That's what it was all down to.
It was St. Kevin. Yeah. Absolutely. I mean, he had the bear case and a fan to go with it. So, I mean, come on, guys.
Oh, yeah. A giant bowl of candy. He had, Yeah.
So, anyway, meeting Spartan, not a problem. There's emails and everything, and you can meet you guys in North America. You have your strategic alliance all over the globe. And again, Rheocasting 2026, I think it's the 9th of January or something. Then we're rock and roll in Europe.
13th to the 16th, I think.
13th to the 16th. Okay. Then we're rock and roll Europe, right?
Yeah, we'll be there.
Yep.
So again, thank you very much for being our guest in the podcast. Very interesting conversations, and we can talk for hours and hours, but you have to end somewhere. So again, thank you for being here, and look forward to meet you again, guys.
Yes, indeed.
Thanks so much.
Thank you very much.
Really appreciate it, guys.
Yeah.
Goodbye.
Thank you.
Right,
it was a pleasure having you. Don't forget to subscribe, and we see us in the next episode. Bye.
See you.